So in this video I'm going to show you some worked examples for the questions that are on the PowerPoint for bond enthalpy calculations. This first one is quite straightforward. They're asking you to calculate the overall enthalpy change of reaction. They've given us a table here that shows the different bonds and the bond enthalpy values. The first thing I would recommend in questions like this is to draw out the structures of these reactants and products. It will make calculating it so much easier, and it will avoid you slipping up with the number of each type of bonds. So I'm just going to draw this out. And you can see this immediately makes it much easier to see what type of bonds we've got being broken and being made. So I'm going to be using this equation here. The enthalpy change is equal to the total bond enthalpy of the reactant, so our bonds being broken, minus the total bond enthalpy of the product, so our bonds being made. So I need to use the values in the table to work out the values of my bonds being broken and the values of my bonds being made separately. So my bonds broken, you can see here, I've got 2 of the C double bond O, which is a value of plus 805 from my table. So I've got 2 lots of 805, which is 1,610. And I've got 4 of the H single bond H bonds, which have a value of plus 436. If I add those together, that gives me a total of 3,354. I'm going to do the same for my bonds made over on the right hand side. So I've got 4 CH bonds, which from my table has a value of plus 415. And I've got 4 OH bonds, which again from the table have a value of plus 464. So that's a total of 3,516 for my bonds being made. Now what I'm going to do is put that into my equation, which is highlighted here. So my overall enthalpy change for that reaction is equal to my bonds broken, or my enthalpy of my reactants, minus the bonds made, or my enthalpy of my products. Bonds broken we've just calculated is 3,354. Bonds made 3,516. So that gives me an overall answer of minus 162 kilojoules per mole. Now this one's quite straightforward because we're just calculating the overall enthalpy change. But if you move forward to slide 8, you'll see a slightly more complicated example, and that's where they're asking us to calculate the bond enthalpy of something in either the reactants or the products. So for this question, this is on slide 8 if you've got the PowerPoint, this one is actually asking us to calculate the bond enthalpy for the bond in carbon monoxide. They've given us the overall enthalpy change for the reaction here. This isn't a problem, it just means we've got one extra step in rearranging the equation. So again, my first step is always going to be to draw out all of the bonds in my reactants and my products. This stops me making silly mistakes with the number of bonds being broken and made. So I'm doing the exact same as before. I'm going to calculate the bonds broken over this side and the bonds made over this side. So my bonds broken are going to be 4 lots of my CH bond. When I look in the table, that's a value of 413. And 2 of the OH bond, which in the table has a value of 464. For my bonds made, I've got the CO bond. I don't know what that is. That's the value that I'm trying to find, the bond enthalpy for that bond in carbon monoxide. And I've got 3 of the HH bond, which has a value of 436, like so. Now, one of the places that people might slip up in this question is forgetting that they've been given the overall enthalpy change for the reaction up here. It's 210 kilojoules per mole. So what I can do is use this same equation as before. The enthalpy change is the bonds broken minus the bonds made. This time I know the enthalpy change and I'm trying to work out the enthalpy of one of the products. So here I've represented my bonds made by 1,308, which has come from these hydrogen bonds here, plus the bond enthalpy for the carbon monoxide. When I say hydrogen bonds, I mean the bonds in the hydrogen molecule, not hydrogen bonding itself. When I solve this equation, I find that that bond has an enthalpy of plus 1,062 kilojoules per mole. It's really important that you put this sign in as well as positive. Remember that positive or negative is indicating whether it's endothermic or exothermic, so that's really important to add that in at the end. So there's one final question on the PowerPoint, which is on slide 9. It's an exam question. So now we've gone through 2 worked examples. If you'd like to pause this video here, go and give that one a go, and I'm going to work through that one as well next. Okay, so our final question is very similar to the one that we've just done. So this one's about the combustion of ethene. They've given us the equation here, they've given us the overall enthalpy change, and there's 2 parts to this question. The first one is quite a wordy one. You can see there's 4 lines here, but it's only 1 mark. I'll show you how to answer this in a minute. It's quite a stock answer question. And then the second part is the calculation. It's really similar to the one we've just done, except this time we're finding the bond enthalpy of the C double bond C bond in ethene here. So our first part, like I said, is a stock answer. Now when they say, explain in terms of bond breaking and bond forming why a reaction can be exothermic, you need to talk about these 2 processes and the balance between them. So we know that bond breaking requires energy. It's an endothermic process. We also know that bond forming, or bond making, is an exothermic process. It releases energy. For an exothermic reaction, more energy is released when bonds are formed than is absorbed when bonds are broken. Now, if this question had asked you, explain in terms of bond breaking and bond forming why a reaction can be endothermic, your answer would be identical except for this word here, and you'd say less energy is released when bonds are formed than is absorbed when bonds are broken. The second part of our exam question is our calculation. So just like before, I'm going to draw out my reactants and my products, and that's just going to make it much easier and avoid me making any silly mistakes with the number of those bonds being made or broken. Okay. So just like before, I work out my bonds broken, and this time it's this C double bond C that I don't know the bond enthalpy for, so I'm just going to leave that as it is. But I've got 4 of these CH bonds, which from the table have a bond enthalpy of plus 413. And I've got 3 of these O double bond O, which again from the table have a value of plus 498. My bonds made, I've got 4 of these C double bond O, which have a value of 805, and I've got 4 of these OH bonds, which have a value of 464. So now I can put these values into the equation of enthalpy change plus bonds broken minus bonds made. I know what the enthalpy change is. They've told me in the question, it's up here represented by delta H, minus 1318 my bonds broken are here. These are the values. I don't know what C double bond C is. That's what I'm trying to find out. Minus my bonds made, which is 5,076. When I solve this, I see that the enthalpy change, the bond enthalpy for the C double bond C is plus 612 kilojoules per mole. If you're not sure how to get to that from this step, this is some quite basic mathematical rearranging. Maybe go back and have a look at a GCSE textbook for that information.